2. 4 objectives for this video, and hopefully you read them and can do them when we're done. All right, so we're talking about calculating rates. So just remember that rates is always something over time. All right, something over time. So what we're going to be using is concentration over time. We'll be using the molarity. So it looks like in this reaction, something is decreasing its amount over time. So this must be the amount that the reactant in a reaction is decreasing. So in order to calculate the rate, you need to use the change in concentration. Concentration means molarity, so the change in molarity over the change in time, over change in seconds. So how do you calculate that? Well, the molarity goes from 0.025 minus 0.048. Now I know it's going to be a negative number because the concentration of a reactant will go down over time. And then the time goes from 300 seconds to 0 seconds. And the concentration goes from at 300 seconds is 0.025 when it started, but at 0.048. So a decrease in the concentration over time must be a reactant. So you subtract those, you get 0.023 over 300, and that's molar, and that's second. So you divide and you get 7.67 times 10 to the negative fifth molar per second is the rate at which the reactant decreases overall. So this is the rate of a reaction. Notice it's molarity over time. So if you want to calculate the rate, then you take the concentration over the time. Okay, so in this reaction, we have lithium reacting with water to form lithium hydroxide and hydrogen gas. So we look at the time and we look at what was measured. Notice this time what was measured is the concentration of lithium hydroxide. At the beginning of the reaction, there's 0. At the 100 seconds during the reaction, it was 0.17 molar lithium hydroxide. So if we want to calculate the rate, we need to take the change in concentration, and concentration, here's a symbol. A bracket can be used to show concentration, and we need to take it over the change in time. In this example, the time is seconds. So we take the concentration, 0.17 molar minus 0 molar is 0.17 molar over the time, so 100 seconds minus 0 seconds equals 100 seconds, and then you got to divide it, and you get 0.0017 molar per second. So the concentration of the products over this time span changed by 0.0017 molar every second. And so that's the rate of the reaction because it's a concentration over time. Okay, so now we need to concentrate. So we're going to talk about solutions. Solutions are solutes and solvents. So we measure a solution's concentration by molarity. Molarity means moles of solute over liters of solution, so the units are mole per liter. So the concentration of a solution describes how much solute is in the solution. So if we have a solution with a lot of solutes, okay, look how much solutes in there now. I know you can't see it actually because it's dissolved, but if there's a lot of it, it's got a high concentration, lots of particles. So an example of lots of particles could be a 6 mole. Example. Now, there are other kinds of concentrations that could be solutions that could be concentrated too. Dilute means not a lot of particles, okay? So not so many solute particles in the same amount of liquid solute particles. So let's just take that to be maybe 0.5 molar. Okay. So dilute, concentrated. So high molarity means lots of particles, high concentration. Dilute solution means not so many particles, and so it's called dilute. Okay. So we can dilute solutions ourselves. What if there are 5 moles in 0.5 liters of a solution? What is the molar? Okay, so we'll just say this is half a liter, and we have 1, 2, 3, 4, 5 moles. So what's the concentration? Well, concentration is molarity. Molarity equals 5 moles, and it's divided by liters, 0.5 liters. Concentration of this solution is 10 molar. Well, that's pretty concentrated, right? What if I add more water to this? So same container. Now we have this much water. What changes? Well, the volume of the water changes. Volume. Right? What stays the same? Well, I didn't add any more moles, so we still have 1, 2, 3, 4, 5 moles. Moles stays the same. Now, which solution is more concentrated? Concentrated. And these are just compared to each other, and this is dilute. But what's changed? What stays the same? Well, all we did was add more water, so the volume goes up and the concentration goes down. But look, the same number of moles. Moles, I'll put moles in here equals moles in here. All right, 5 and 5. Okay, so here's another visual of it. If you look at this, this is concentrated. 1, 2, 3, 4, 5, 6, 7, 8, 9. You counted those. If you add more water to dilute it, you add a solvent, and you still have the same number of moles, but it's in more volume of liquid, so it's less concentrated. Okay? So the moles of the solute before you dilute it is going to equal the moles of the solute after. And the I and the F stand for initial and final. We're going to change those to 1s and 2s, but it'll mean the same thing. So you're going to have to do dilutions because dilutions will help us determine rate. Okay, so you dilute a solution by adding more solvent. What solvent do we usually use? Usually water. Okay. So what will the new concentration be? Well, if moles are the same before and after, and it's the volume that changes, then because the volume changes, the molarity is going to change, but the moles stay the same. So how do you get moles? Well, molarity is moles per liter. If you multiply that by volume, that equals moles. Okay? So over here we have molarity, and we have volume. So if you multiply those together, that's moles in the first solution, and then we'll get a new molarity, a new volume, but if you multiply that together, it equals the moles of the first solution. So what stays the same? Moles. What changes? The concentration and the volume change, but when you multiply together those two quantities, the moles stay the same. So we're going to call the 1s the more concentrated solution, and the 2s will be less concentrated. If we stick with that, we'll be able to do the problems the same each time. Okay, so let's practice. So what do we got here? We got 150 milliliters. That looks like a volume of 2.5 molar HCl. That looks like a molarity. Is diluted to 300 milliliters. That looks like a volume. What is the new concentration? Molarity. So now we just need to decide what is before and after. Okay. So this is 150 milliliters of 2.5. It's diluted. So this must be the original, M1 and V1. And these must be after we diluted, M2 and V2. So the original molarity is 2.5 molar. The original volume is 0.15 liters. What? Okay, so if you have milliliters, you just move your decimal point 3 places to get liters. So the molarity of the second solution is what we're looking for, but the volume of the second solution is 0.30 liters. So then just plug it in the calculator in the problem. Make sure you memorize this. So have this memorized. So we just take the M1 V1 equals the M2 V2, and we plug them in. 2.5 molar. Look, I'm putting the units in to help me. Times 0.150 liters equals the x, what we're looking for, times the 0.30 liters. If I want to solve for this x, I got to get rid of the 0.30 liters. Goodbye. And I bring it to the side, 0.30 liters. So then I would just multiply those together and divide by that. Look what happens. See you later, liters. Hello, molar is the only thing left. When I multiply that all together, I get 1 point and divide by 0.3, I get 1.25 molar. Okay, so that makes sense. Well, we start with 150 milliliters of that. We dilute it to 300 milliliters, which is double the volume. We get half of the concentration. Okay. So this is the new molarity. It's dilute. Okay. Now this one says how much 4 molar KNO3 solution, right, so that's a molarity, would be needed to make 450 milliliters, that's a volume, of 1.4 molar canister. That's a molarity. So let's decide what goes together. This looks concentrated. That looks dilute. So we're going to call this a 2 and that a 1. And this goes with that. So that's going to be a V2. So what we're looking for, how much is going to be our V1? So our M1 is 4 molar, the higher concentration. Our V1 is what we're looking for. Our second concentration is 1.4 molar, and it's smaller, so it's dilute. And we need to make 0.450 liters of that. Okay, so we solve. M1, V1, memorize it, equals M2, V2, memorize it. So then we plug in M1, 4 molar. And hey, that's what we're looking for, V2. Plug in M2, 1.4 molar, and 0.45 liters. Alright, so I need that exercise. Divide through by 4 molar, 4 molar. Hey, look what happens to the molar. See you later, molar. Where we left with liters. Alright, so you multiply those together and divide by 4. And you get 0.1575 liters. Now, you take this up here, I'm going to show you what it means. It means 157.5 milliliters. So what does that mean? That means we need this much of the concentrated stuff, and then we add water to it until we get 450 milliliters. So we got to dilute it. All right, so you're going to have to do it. So we're going to practice calculating and what it makes to make the solution in lab. How would you make 50 milliliters, that looks like a volume, of 1 molar, that looks like a molarity, from 6 molar, that looks like a molarity. So what's missing? Another volume. All right, so let's decide what we have. These two numbers go together because it says of that. And this looks dilute, so I'm going to put a 2 and a 2. This is concentrated, so it's going to be a 1. So we're missing our V1. So the calculation is M1 is going to be 6 molar. V1 is what we're looking for. M2 is going to be our 1 molar HCl. And the volume of the 1 molar HCl is going to be 0.050 liters. Alright, so let's get 6 molar times X. Remember, M1V1 equals M2V2. Alright, that's going to equal 1 molar times 0.050 liters. Hey, get rid of that 6 molar. How? Divide. Put it on its side. How? Divide. So that goes away. But look, molarity cancels molarity. We're left with liters. And the answer is 0.00833 liters. Okay. This is a small number of liters. But if I want it to be milliliters, I move my decimal point 3 places to the left. So I'm going to get 8.33 milliliters. So what the heck does this mean? Well, because we were looking for a V1, this tells us how much of 6 molar we need to dilute. So, description of dilution process. Measure 8.33 milliliters of 6 molar HCl. Then add, what do we add to dilute? Water. So we get 50 milliliters total. Then we'll have, so if we take 8.33 milliliters of this and add water, it's going to dilute that. And we're going to get 50 milliliters of a 1 molar HCl solution. So this is going to be less concentrated because we diluted it. Okay, that's molarity and concentration and dilution. So the last objective we didn't cover yet was how temperature affects average kinetic energy. Okay, so we saw this picture in class already, but this is low temperature, and so these molecules are moving. Okay, temperature is a measure of the average kinetic energy. So these at a low temperature, they're moving because they're affected by temperature. Now, if you increase the temperature, okay, so this is low temperature, this is high temperature. So what happens when you increase the temperature? Well, as you can see, these arrows get bigger. Okay, that's just a visual, but a bigger arrow means more energy. So high temp means higher kinetic energy. Higher temp means higher kinetic energy. Low temp means low KE. All right, so if we're talking about collisions, these molecules have energy, they're moving, but when they collide, they don't have as much energy as these molecules. So which reaction will be faster and with a higher kinetic energy? Because when they collide, they have more energy, so there's more chance that the collision will be effective because they have higher energy. Right? So as you increase temp, means you increase kinetic energy, and so the molecules have more energy, and so they're going to collide more often because they're moving around more. Kinetic energy is energy in motion, and they're going to collide with more energy, so those collisions may be more effective. All right, so yeah, look what we just did. We explained how rate is determined and how rate is inversely related to time. We calculated the rate of a reaction is concentration over time, so molarity over seconds. We described how temperature changes affect kinetic energy, and we calculated dilutions of standard solutions that are concentrated to make them more diluted. All right, that's it. Peace out. See you in class.